Let's go through this example together. Bacteria are growing according to this formula, B equals 4,000 multiplied by E to the power of 0.1t, where t is the time in hours. Now we need to answer all of these questions to three significant figures. So the first one simply asks, how many bacteria are there after 5 hours? Well, what we want to do here is let t equal 5. We know that t is time in hours. And simply sub that in and find out what B is, because B is the number of bacteria that we'll have. So B will be equal to 4,000 times e to the power of 0.1 times 5. Now it's tempting to put in your working 0.5 here, and if you're confident with your mental arithmetic, go for it. One advantage of not doing that and literally just subbing what you need to into your formula is that if you made a mistake there and instead of 0.5 you put 0.05 or something like that, if you have that wrong and then the next answer is wrong as well, it's very hard for an examiner to give you a mark. But if you've made your substitution and it's all correct and then you press the wrong button on your calculator, you'll generally get a mark for this line. So next, reach for your calculator. We'll need to type in 4,000 multiplied by, now to hit the E, remember you need shift and then the LN button. And then up in the little box, you can just type in 0.1 times 5. Now, feel free to put 0.5 in there, but the less that you can make a mistake with, the better. So since you've got your calculator open anyway, you may as well do this. Now, we haven't yet rounded to three significant figures. This is what I recommend doing next. Write down the answer that you get on your calculator. 6594.885083. Now I haven't yet rounded it to three significant figures. This is the answer my calculator gives me. But on the next line I'll say that's approximately equal to, which you can do the dots here. You can also do this symbol, an equal sign that's wavy, to show that it's approximately equal to. Now if we want three significant figures, we need the 6, we need the 5, we need the 9, and we need to cut it off there. Having a look at what's left though, 4 is less than 5, so we've got roughly 6,590. Okay, and that's to three significant figures because it only has three figures that aren't zeros, and that gives the rough size of the number without all the detail. Okay, next one, find the rate dB dt. Now let's just check we understand what that means. That means differentiate the number of bacteria with respect to the time. So we're looking at this formula and differentiating for t. Well, we know how to do that. We need to just take this 0.1, because if we differentiate the power here, it's just saying how many t's are there. Well, there's 0.1 of them. So the 0.1 comes down the front. So what we get is 0.1 times, and then we need to just rewrite the rest of our expression, 0.1t. Now, the other way you can go is to think, well, I know what 0.1 of 4,000 is. It's 400. So you could do that on the next line, or you could have done it straight up. And we have 400 multiplied by e to the power of 0.1t, and we're done. For part C, it says, what is the rate of increase after 5 hours? Now, you need to think what the rate of increase is. The rate of increase in the bacteria is the change in bacteria with respect to the time. It's the steepness of the curve, if you like, isn't it? So what we need to do is we need to find what the gradient is, because that will tell us what the rate is at the 5-hour mark. So let t equal 5, and we want to sub t equals 5 into this, because that will tell us the rate of increase. So let t equal 5, dB dt is going to be equal to 400 times e to the power of 0.1 times 5. So again, we'll need our calculators. This is a similar calculation to the last one. 400 multiplied by shift ln, and then you can put in your 0.1 times 5, and what we get there is 659.48858083. Similar number to this one. All right, I need three significant figures, so rounding it off, I need it to be only this big, so it's closest to 659, not 660, so that's my answer to three significant figures. All right, part D, what is the average rate of increase in the first 5 hours. Now, I want you to have a think. If we've graphed this thing, let me grab a little bit of spare space. If we've got time going up and our number of bacteria is going up like this, imagine at the 5 hour mark, the rate of increase could be a certain thing. That will be the steepness of the curve right there. But the average rate of increase, we'll need to know how many bacteria did we have in the beginning, how many bacteria do we have now after 5 hours. The average rate of increase is actually a secant between the two. Now, you can think of it as a secant, or you can just think, well, in the beginning, how many did we have? And after 5 hours, how many did we have? And then we'll just look at how many we got in the 5 hours per 5 hours and write it as a rate. Either way, we're going to need to find out how many bacteria we had at the start. So when t is equal to 0, bacteria was, well, let's sub 0 in here for t. 0.1 times 0 is nothing. E to the power of 0 is 1. So we've got 4,000 times 1. So at the start, we had 4,000 bacteria. So I would write this as the average rate of increase. And think about what you know. Well, we know it's gone from 4,000 bacteria up to 6,590. In fact, it's closer to 6,595, isn't it? But we can use either of these figures. It would be better to use the top one because it's actually going to be completely accurate. And we don't want to round things off twice. So if we take this number, subtract 4,000 from it, we get 2,594, and you can put all of those decimals in there if you like to keep it as good as you can. Now that's what we get, every 5 hours. So what is the rate per hour? Well, if you write down a rate and then you write down another rate that you want below, you can say this is to this as that is to that. To get from 5 hours down to 1 hour, I've just divided by 5. So obviously over here I need to divide by 5. And I'm going to get around about 519. Now we're going to 3 significant figures with this. So that tells me to round it off to the exact number. So the average rate of increase is 519 bacteria an hour. Not that we got that all the time, but that would be the average. All right, when? This is a different sort of question. So we're going to find T. We don't know when it is. When are there 10,000 bacteria? Well, this is our formula for bacteria. What we need to do is we're finding T and we want to know when the bacteria are 10,000. So I'm going to write the formula by subbing in 10,000 for the B and then rewrite the rest. 0.1 T. Now, looking at that, to tidy this up, the easiest thing to do first is literally to divide by 4,000 on both sides, right? So if I get 10,000 divided by 4,000, this side's going to be 2.5, and this side will just be e to the power of 0.1 t. All right, what to do next? We need to get the t by itself. So here we've got an index expression, and the thing we don't know is what's in the index. So we need to rewrite it as a log. Normally I go underneath. I'm just moving across here because I don't have all that much board space. So e to the power of 0.1 t is 2.5. I can write that as a log. E to the power of 0.1 t is equal to 2.5. Okay, so how do I get the t by itself when I know 0.1 t? Well, I can multiply both sides by 10, can't I? That will give me t here, and here I'll have 10 lots of this. So I can say t is equal to 10 lots of log with a base e of 2.5. And that's now just a number that I can type into my calculator. 10 times, remember to hit the natural log button, put in 2.5, and we get time is equal to, now, this is the number that's going to come out. But remember, this is hours, isn't it? We want this to 3 significant figures, but we also want it to make sense. So if I say to somebody, I'll see you in 9.16 hours, they're going to say, when is that? So at this point, let's hit the time button. That's the one that looks like this with the degrees symbol and then the comma and the 2 commas. If I hit that, it's going to change it to 9 hours, 9 minutes, and 46.47 seconds. So putting that to 3 significant figures, okay, we could say 9.16 hours. That is 3 significant figures, and that is what they asked for. But let's just make sure we know how to change it to 9 hours and 9 minutes. And then we've got some seconds there. Let's say 47 seconds. All right. Now the last question says, when are they increasing at 10,000 per hour? So let's rub out something at the top here to give us a little bit more space. We'll rub out this one and this one. Now, when are they increasing at 10,000 per hour? Well, we've just rubbed out our dB dt, so I should probably write that down again while we're remembering that we need it. So we've got this. Now, we want to know when the rate of increase is 10,000 per hour. Well, this side here is the rate of increase, isn't it? So we want to let dB dt equal 10,000. And we want to find when that happens. In other words, we want to find the value of t. All right, so moving on down below, but I'm going to work going across. I've got 10,000 has to equal all of this. So the working here is really similar to the last question. Start by dividing both sides by 400. So easy way to do it. It's the same as dividing 100 by 4. So we've got 25 is equal to e to the power of 0.1t. Now we can rewrite this as a log. We have e to the power of 0.1t is equal to 25. So if we want to find t by itself, we need to multiply both sides by 10. So t is equal to 10 lots of this. 10 times log base e of 25. So reaching for my calculator now, remember to hit the natural log button again, and we get time is equal to 32.18875.825. Now here again we've got the dilemma, we've been asked for significant figures. It's not all that usual though to write a time in hours as 32 point, we'd need 2 here, wouldn't we, if we're doing 3 significant figures. Because 0.2 of an hour doesn't make all that much sense. Mind you, we could round it off to 0.2 of an hour and then we could hit the time button and realise that that's 32 hours. Hitting the time button here actually gives you 11 minutes, 20 seconds. We know that 0.2 of an hour though, that's a fifth of an hour, that's 12 minutes. So you can take your pick there of whether you write down that it's 11 minutes or 12 minutes or just leave it like this. I think in the answers they actually want it like this, even though it doesn't really seem all that logical to write time in decimal form.